Hey guys, welcome back to Quick Code. Today we're doing another Brainstellar Quant puzzle. This one is called Dead Man Walking. It's a medium problem. I'll let you guys pause and go over the problem once. So let me explain the problem first of all. So we've been given these 100 zombies walking in this straight line as drawn over here. And well, in the question it said that they are randomly assigned to be walking either towards the right or towards the left. Well, in my opinion, it's better to visualize this as walking forward in that straight line or backward in that straight, right? So this is like a 1D straight line, and they're either walking forward or they're walking in the backward direction. Now they are also evenly spaced out. It's mentioned 1 unit of distance between each zombie initially. So the question is that given an arrangement of these 100 zombies, and so we'll also be assigning a random arrangement of either walking the forward direction or backward direction, each of these 100 zombies. So given this random arrangement of forward and backward direction, we have to tell if there is a neat and fast way to calculate the total collisions that'll take place over here. Now, what is meant by a collision? So, if you see these two zombies over here, Z2 and Z3, since one of them is walking in the forward direction and Z3 is walking in the backward direction, both of them are gonna collide, right? And once they collide, so this is before collision, then the collision happens, and after the collision, Z2 is gonna be walking in this direction and Z3 is gonna be walking in this direction. So yeah, so given a random arrangement of forward and backward directions for these 100 zombies, is there a neat and fast way to calculate the total collisions that will take place in this system? And we have to do so without having to be need a brute force type of manner to calculate this. So, I mean, one brute force way would to simulate every single collision and each state after and before the next collision, and like try to manually calculate in a brute force manner how many total collisions took place, right? Now, that is what we aren't supposed to do. We have to come up with a smarter way of just looking at the system initially and somehow calculating with a proof of how this is possible, how that makes sense, the total number of collisions that will happen. So, just to make this question more concrete, let's consider an example. So, I've given a random arrangement over here. One of the possible arrangements that could be happen is, let's say these 50 zombies were walking in the forward direction and these 50 zombies were walking in the backward direction. So, given this particular arrangement, can you guys just look at this arrangement and quickly calculate the total number of collisions that are going to take place? Now, at a first glance, you might think that calculating this will take a lot of time because, well, first of all, these two are going to collide and both of them are going to reverse directions, and then these two are going to collide, and then these two are going to collide, and there's going to be so many collisions and so many reversals of directions, and it'll soon become a very random or chaotic state where you can't really just easily calculate the total number of collisions that are taking place, right? Well, the hint to this problem is, well, first of all, it's important to understand that this question is built upon a very famous trick. So, the trick, I'll try to hint you guys towards thinking about the trick. So, think about a single collision. Now, when two zombies collide, and it's also important to understand that at any given moment, only two zombies will be colliding among themselves. So, what happens before a collision? So, before any collision, we will always have one zombie walking towards the right or left, and one zombie walking towards the left, right? Now, I'm just using the question's directions. So, this is always going to be the case before a collision, and then the collision happens. And after the collision, we will always have one zombie walking towards the left and another zombie that will, once it reverses direction, will be walking towards the right, right? So these are the two pictures that we are going to see before and after collision, right? Now here's the trick. Instead of imagining them as colliding and after the collision reversing their directions, imagine them just, let's say, high-fiving each other as they pass by, or imagine them as ghosts, right? So instead of colliding, they will just pass through each other. Now, how does this change the question? Now, if we just consider, instead of each collision being reversal or directions, we just consider that, so if these two zombies were going in this direction, then they just high five each other, and this zombie over here just keeps on walking in this direction, and this zombie over here just keeps on walking in this direction, and we just count out all the high fives or all the pass throughs that happen in the system, we will come to the same answer. Now, why is this? Well, if we look at the ghost approach or the passing through approach, before every collision, we have the exact same scenario, right? One zombie is going like this and one zombie is going like this. And then let's call the collision as, in this case, just passing through each other. Now, after every pass through, we're always going to have one zombie going towards the right now and one zombie going towards the left, right? So these are our before and after cases. So yeah, so this was the case of before and after when we were considering collisions. And this is the before and after case when we're considering them to be ghost zombies and just passing through each other. As you can see, the before and after case is completely identical from the POV of the system. Before we had one zombie and one zombie in these two directions, and afterwards we had one zombie in the opposite directions as shown over here. The difference is that this particular zombie is now going in this direction, whereas for the earlier collision case, this particular zombie was this zombie, but this will not matter, and I'll explain this next. So if you pause right now and try to think about it, yes, we did change the effective collisions any particular zombie will go through because of changing them from colliding to just passing through each other. For some particular zombies, the number of collisions that he will face will change in this approach. But from the entire system's POV, we still have two zombies going in these two directions, and afterwards we have two zombies going in these two directions, which from the system's POV is completely identical. And all we need to do is, in this case, we were counting each collision as one increment to the counter. In this case, we just need to consider each pass through of two ghost zombies as an increment to the counter. Right? Try to pause over here and think about this particular point. That yes, we do change the number of collisions for each particular zombie, but from the entire system's POV, the before and after of these two approaches is exactly identical, which will lead us to calculating the total number of collisions of the entire system. Calculating this counter will be identical in both cases. So the effect on the overall system hasn't changed. So if we come back to calculating the number of collisions using this passing through approach, all we need to do is for each zombie going towards the right, we have to first of all look at all the zombies towards its right, which are going towards the left. Discount all those zombies. And we do this for each zombie that was going towards the right. So for example, in the 50-50 case, right, we had 50 zombies going towards the right, and we had 50 zombies towards the right, which were going towards the left, right? So for each zombie, let's say for this first zombie, calculate, we add up all the zombies to the right of this zombie that are going towards the left. That would be 50, right? Now for this zombie, we would do the exact same calculations. That would add up for 50 more. We would add these 50s for 50 times because there are 50 zombies over here. That would come out to be 50 into 50, 2500 total collisions. So for the example case that I gave earlier, there are guaranteed to be exactly 2500 total number of collisions. This was the Brainstellar solution written, and this is the exact same meaning I've just provided here so that you guys can pause and read the solution and try to understand even better. Hope you guys understood the solution, and thanks for watching.